And if is there any question, I can answer.
I have a question. So I haven't taken the GAN workshop, so I'm actually a little quite ignorant about GANs. I understand the concept, but how does the discriminator provide the feedback to the generator? I understand that it can discriminate, but how does it incorporate that into the...
So how you are training a neural network?
You have your loss at the end, and then you back propagate the
So you
loss.
have a loss.
Yeah.
So instead of getting the loss, let's say from the generator itself, you're getting the loss from the discriminator.
So the discriminator says 0, 1, and then but then what happens?
Then you're using that loss as your loss here. So see, the loss here can be a number, right? So at the very end.
But doesn't that just mean, so in the extreme case of 0 and 1, this means I'm only going to actually apply training passes on when it discriminates true. Is this what you mean?
It's like that. So generator will produce something,
Yeah.
and then you will use it
Mm-hmm.
because the discriminator is exactly right after it.
Mm-hmm.
Then if you go through the discriminator,
Mm-hmm.
an score will get generated. A score can be 0 or 1.
Okay.
For generator, you're reversing that score. So if the discriminator if the discriminator says, okay, that's generated, which is 1, so for the network is super bad because there's for the discriminator the loss will be 0 because it managed to get good score, right? Because it actually was generated, and for the discriminator it is generated. For the discriminator the loss is 0. 1 minus 0, the loss of discriminator will be the loss of the generator here. And then we're saying, okay, no, your loss for that layer, pull back, is actually 1. So you got maximum loss. Do something. And then we're going forward again.
And that's how this works?
That's kind of is working, yes.
But that's how it's implemented here?
Yes.
Okay. But in other papers it might be different, but it's a variation on that theme. But if you were to, because if you just provide 1, that doesn't seem like, shouldn't the loss reflect, shouldn't use it as multiplied, maybe use it as a factor to, I don't know, does it make sense?
That's what I'm saying. They are not just one GAN, there are actually, this is the simplest basic version of the GAN that was out there a couple of years ago by Young Goodfellow. And after that, even if you look at the image that he generated back then, his blurry is like that. But if you look at all the images that you can see right now, it's super great. And you are right, because they're not maybe using the same technique here. Maybe they're using all other different loss, different metrics. They're using, I don't know, instead of just using 0, 1, they're using, I don't know, difference between the probability of this input and output. They're using lots of other technique to make it better and better and better. And after a couple of years, if you just see how was the trend of all the model that has been generated for GAN, there are lots of ways that you can actually do it, and we are not. And I would say we are not even there yet. We are still working on it, trying to make it better and better.
And then in the actual train, I know, and when you build the model, you have.
So the thing I tried to do that here was like the simplest, easiest way that you can implement GAN.
Okay.
To give a good number.
Okay, but just to confirm though, you set when you do the GAN model function, you've set .trainable to be false, but then later on you will go and actually take specific parts of your training loop to go and improve the discriminator,
Yes.
right? Okay.
Because I have two models. If you go up, you will see that here I'm making a generator. Here the discriminator, I'm making the discriminator and compiling them. The discriminator will be one closed model.
Yeah.
And then for the other one, I'm just saying that, okay, use a generator as well for that, so for the second model, make a discriminator part of the model not trainable, use it, and then
validity.
get some result. Exactly. Then that model is a model from input to 0, 1 prediction, which this discriminator part is freeze. So it's frozen. So
For now or forever.
for this model. So
Okay.
you have two models, discriminator and this model.
Yeah.
And you're switching between these. So for this one, it will see the real data and the thing that you will see from this one. And then you're switching to this one. So it's like, that's what I say, it's like a two model playing with each other. So that's why even when I was producing result, so there is a two loss. The loss of the just discriminator one and the loss of the other one.
Question online? Can I just say question? So the question is, how would conditional GAN help anomaly detection?
Well, I can't see the question. Okay, so you
It's from Willie. It's probably from in the handout.
okay.
How would conditional GAN help with anomaly detection? Could you repeat the question because I don't have it?
How conditional GAN will help with anomaly detection?
Yes.
If you don't have any condition for your GAN, the thing that you're producing can be anything. So you can actually use it for any kind of anomaly detection. The thing is, the whole thing that we are talking about here is kind of like a conditional GAN. And the condition is actually the input itself. Because it is GAN, but instead of me computing the metric between input and the constructed one, I'm using the GAN techniques to be able to tell the difference between these two. And let's say if I don't have any condition, it means I just have the decoder part. And the decoder part, based on some prior, will generate a sample. Then I should be able to, then from that moment, maybe I can just use a discriminator to tell the difference between any generated image and the real one. So it's like, can I tell the difference between bunch of noise and the real data? Then the discriminator will learn that one, which is not exactly bad thing. Like, remember when I was just shuffling the data, I said it's like a dumbest one. So still you will learn something, but if you have a condition, you will learn something which is based on the actual input data. So you should be able to come up with the score for your anomaly detection. Any question here from, because that's the last session, we can talk about anything related to other detection in the last 10 minutes.
So is it, if I understand correctly, you take a GAN, if you replace the discriminator with a fixed function which tells you KL divergence between the latent space, conditional discriminator which can extract the latent representation. So if you take the discriminator, replace it, it's lost by a KL divergence between the
Input and output?
latent representation, latent distribution, and normal distribution in the latent space.
Yes. They call it
exactly.
That will be VAE.
Yes. So it will be exactly VAE.
Yes. And if you have the discriminator, instead of telling the difference between input and output, tell the difference between the discriminator one, tell the difference between the latent space and normal, it will be AAE, adversarial autoencoder. Yeah, AAE, adversarial autoencoder. It's like if the discriminator will tell the difference between input and output, it's GAN. If you tell the difference between the latent space and the normal distribution, they call it AAE. No, not normal distribution. Gaussian distribution.
Are those, you had in your slides for the arbitrary probability distribution functions with the cube, like there was a starburst made out of
Yeah. That was a
normals, and then there was
that
a
was actually
spiral.
that picture was based on a conditional AAE. That's why there was a color. Is like it says that's is like make it to be Gaussian, but you have a condition as well. So you have to make them to be close to 0, but they still be separatable because based on that you want to generate something.
Which is that's a VAE style, because you have the multi.
Yeah, but VA is
The-
not conditioned, so it will just make it to be close to 0.
But the VAE has the condition that it's a mixture
Yes,
of Gaussian
yes,
model.
exactly. So yes, because the input is there, it to be able to reproduce it, it should kind of make something like that as well. Yes.
Yeah.
Yeah. There are lots of ways that you can play with all these layers and to enforce it to be similar to any kind of distribution that you want, using GAN, using just scale divergence as a regularizer or different technique.
In general, if provided nothing bad happens, like the degenerate case we saw with the instability in training, are GANs a general tool that you can apply to any autoencoder like problem? And do they work? Oh, there's two other questions I had. So, in this sort of feature detection, anomaly detection world, if you're trying to look for features, sometimes you see a lot of stacked autoencoders or these deep stacked autoencoders. And can you do that with variational autoencoders as well? Can you stack variational autoencoders? Does that still make sense?
Yeah, but that's overkill, right?
Yeah.
Because for that is like, I guess they're not doing that anymore that much. They basically back then they were doing that for pre-training of the model.
Mm-hmm.
I mean, you can still do that for other reason, not just for classification. But back then they were just using any kind of metrics. And whenever you have a matrix, for sure you can have a discriminator for that. But let's just imagine having a discriminator per layer, train it, go to the next one, do that. You need lots of data because you have lots of parameter in your discriminator, and then you have to balance them, go to the next one. So it's like, yes, if you want, you can do that.
Mm-hmm.
But do you want to do that? That's the question. But yes, it's possible.
Yeah. So, and then back to the first question though, can you, in general, attaching a GAN to one of these sorts of problems, attaching the adversarial aspect is one way to improve performance if you're stuck? I.e., you have a specific architecture and you keep running into the same minimum.
What was the question again?
If you involve a discriminator and set them up in this adversarial relationship, in general, is this a way to begin to move past a local minimum that you keep encountering without changing features?
The discriminator is okay. The problem is the reason that it cannot converge is at the very beginning the discriminator is not good enough. It's basically random. So the metric that you're defining at the very beginning, it has some reason. You're saying that these two should be similar based on the metrics. But let's say just you're starting with your GAN, and the thing that the discriminator will predict will be just random because the weight is random. So it will kind of destroy the generator at the very beginning. And then you're saying that along the way, it will get better, hopefully, if everything is there and if generator is not that good. That kind of, see, if at the very beginning, if generator is super good, the discriminator won't get a chance to get better at all. And if discriminator can't get the chance to get better, it won't be able to make the generator to be good enough. So it means you should find a balance between them. If at the very beginning generator is better, then it will still like it will still like that. If the I don't know the discriminator is better, the generator won't be able to improve at all. So finding the balance between them, trying to make them to grow together. This is like a kind of like a technique that they're trying to do that, and they're saying that convergence of the GAN. So it's not trivial, but maybe it's a path forward.
Okay. Question from online. If our data is unsupervised, how are we conditional our GAN?
You can still do that. The whole idea of using any kind of neural network is the neural network can handle noise, because sometimes there are some models, especially those who were more sensitive toward any kind of outlier in your data. It was harder for them to do anything. For a neural network, usually they're not that sensitive toward any outlier in your data, so they still can learn the data. That's why sometimes there's a loss. The model won't be perfect at all, and those loss will be maybe the price that you're paying to be able to ignore all those outliers in your data. And that's why, yes, they can handle unsupervised one. And the thing is, I would say I should even add that if the definition of anomaly is actually a bunch of nodes in your data, but if you have like a systematic group of nodes, which all of them are kind of anomaly in your data, let's say in a network, there's something suspicious happening, but always happen in the same way that you have enough data for it, then none of these models should be able to capture it, because then it will be kind of like a new normal in your data set.